Welcome, welcome, welcome. So everyone having a good reInvent so far? Well, that was kind of weak. All right, so we'll jump right in here. We've got a lot of content to cover. My name is Bob Odell. I'm a senior product manager with CloudTrail. And CloudTrail, which you'll learn here if you don't know, is part of AWS management tools. And we're going to talk a little bit about how AWS management tools really helps enable governance, compliance, and some of our operational and risk auditing. So what we'll kind of cover and what to expect from our session here today is I really want to go through and kind of level set an overview of what governance and compliance is. I'd like then to spend just a few minutes on some of the challenges that we all face today, provide a brief introduction to AWS management tools, look at some of the capabilities, and we'll go through some demos of a lot of the tools themselves. And then if we have any time, we'll do Q&A, or I'll stick around after and be happy to answer any questions. So one of the things that governance, compliance, very broad terms, thought it would just be good to kind of level set again, really what the two are. And in a broad sense, if you think of governance, it's really the oversight role and the process by which companies really manage and mitigate the business risks. In the case of IT, it helps us put some structure around how organizations align IT strategy with business strategy, and really to help ensure that the company stays on track for achieving business goals. Compliance, on the other hand, really helps ensure that an organization has the processes and the controls in place to meet the requirements that are set forth by the governance body. And that can be both internal, it could be external, it could be best practices, it could be any number of international type frameworks. So what really then does this mean? So in order to effectively use IT in enabling organizations to achieve governance and compliance, you really need to kind of focus and do a few core things. And this is where we'll frame AWS management tools. And that's what this looks like. So one of the first things that you really need to do is define what is IT supposed to do. Once you're able to define, and definition could be around a business rule, it could be around a process, it could be around a standard. It's really defining what IT is. The next thing you'll want to do is focus on discovering, so what IT resources actually exist. Once you're able to discover those, monitor what IT is doing. And finally, you're going to want to manage, respond, and report to changes in those resources. And really, are those resources and the configurations around those, are they compliant with the business rules that I defined when we set out on this? So that's kind of, keep that in mind. That's the framework that will really start to look at the management tools and how each one of the management tool services helps us achieve this. So what is the challenge today? So if you think of traditional kind of on-premise environment, and again, in the definition of define, discover, monitor, manage, those are really, really hard tasks to achieve. And a lot of times, as you look at putting more controls in place, meeting more governance kind of requirements, what happens traditionally in an on-premise is your ability to innovate, your speed of innovation, your agility goes down. And we've seen this time and time. I was recently talking with a customer who was making their migration from on-premise into AWS Cloud. And they described a process where on-premise, they would have controls that were in the number of hundreds, which would add anywhere between 4 to 10 weeks onto a project itself. And it was just standard operating business. A lot of these were very manual types of processes. So what we want to focus on is AWS enables you to do both. And I thought it was great. Did everyone have a chance to at least watch or attend the keynote this morning? So if you recall, we had customers like Expedia and Goldman Sachs talk about how as they embraced and moved onto AWS Cloud, I think I heard things like we were able to stand innovation on its end. We were able to accelerate exponentially our innovation. These are things that are accomplished in AWS because we allow you to programmatically define the provisioning and configuration of your resources. We allow you to easily and across a large scale discover new resources and changes to those resources. We allow you to monitor them for operations and for compliance. And then last, we make it really easy for you to manage, report on, and respond to any changes. And that response could be alerting and notification. That response could be auto remediation. So you could actually take it as far as to automate the response to changes that are not compliant. And we'll talk about how to do some of that. So I wanted to introduce the AWS management tools, which again is a category of services. So if you go into the AWS console today, you'll see the category AWS management tools. And these are the suite of tools that are inside of that. And if we think again in the define, discover, monitor, these are really kind of where these fit. Are they applicable across multiple categories? Absolutely. But we'll look at them in definition of what we started with here. So if we look at how to define provisioning of resources and the use of parameters throughout our environment, we've got services such as AWS CloudFormation, AWS Service Catalog, Amazon EC2 Systems Manager and Parameter Store. And I don't know if those of you heard the announcement or saw anything about it, but we recently launched AWS Management Tools as its kind of standalone console. So you'll find, even though previously these were Amazon EC2 Systems Manager, you'll now find them also as part of AWS Management Services. So you'll see that now in the console. Under the Discover and Monitor, we've got services like AWS CloudTrail, AWS Config and Config Rules, and then again, Systems Manager tools such as State Manager and Inventory. And then on the Manage, the Report, and the Respond side, we've got services, again, such as Systems Manager Run Command, Maintenance Window, Patch Manager. We've got AWS OpsWorks, both for Chef Automate and AWS OpsWorks for Puppet Enterprise. And then last, we've got Amazon CloudWatch. So we'll run through each of those and again, try to do a demo so you can see just how easy it is to set these up, to enable them, and the value that they provide in terms of governance and compliance. So here's a common scenario. Heard it many times, we've all experienced it. Business unit comes to us, CEO comes to us, executive comes to us, and says, you know, we have to respond to customer needs, we have to respond to competitive pressures, and we've got to develop or revamp a new application in order to do that. And oh, by the way, it's got to be done yesterday. There's never a reasonable timeline associated with the request. We've got to do it at no cost. We didn't budget for it this year, so we've got to just do it, you know, bare bones and just get it done. And we've got to ensure compliance, by the way, with all of our current practices, all of our controls, and all of our security and risk auditing. And these are the types of projects that really keep the CIO, the CISOs, the CFOs up at night, right? Because now you've got this small group, usually small group of individuals, that's now got a mandate to focus on speed, to get things done, which typically means you've got an opportunity for a rogue server to show up. Never happened, but it has, right? So it's a engineering desktop machine that's connected into the corporate network that has all the dev tools on it that nobody knows about. But yet that's what causes issues sometimes. So These are the types of projects that we're constantly faced with, but yet also represent some of the largest risks for traditional on-premise enterprise. So let's take a quick look then at each of the tools, and we'll break those down again in that scenario. And let's start with the define, provisioning, and configuration of resources. So a question to ask: how can I programmatically deploy AWS resources in a very orderly and predictable fashion? And the service to do that is AWS CloudFormation. So just a quick question. How many of you have already used CloudFormation? Excellent. So a good number of people. So for those of you that haven't, or for a refresher for those, AWS CloudFormation is a service that really provides kind of a common language. And it lets you describe and provision infrastructure resources for AWS. And it's really composed of think of three main components. The first one is a template. And templates could be selected from a set of sample templates. AWS provides that, and we'll take a quick look at it. It could be anything from a engineering development desktop to an entire framework, application framework, very complex. Templates can be designed either in a visual editor or through a document directly. And today, CloudFormation supports both JSON and YAML. And then templates basically require resources to be defined with options, with parameters, with metadata, with mappings, conditions, and transforms. So extremely powerful in how you can provision a resource in AWS. Change set is another component of CloudFormation, and very important to understand. Before making changes to resources or deploying, create a change set. And really what a change set does is it allows you to see how your changes will impact any existing resources. And then once you get that, in order to deploy a CloudFormation template, you create a stack. And a stack is really the resource then that does the deployment for you based on those templates. Now this summer we launched stack sets as well. So if you want to deploy a stack across multiple accounts or multiple regions, you would create a stack set to do that. But same concept, you'll use a template and define what those resources should be, what the settings are around those, and then be able to deploy it either through a stack or a stack set. So think of CloudFormation templates really as code, and treat them as such. Put them in your source code repository. Put inline comments. They're very declarative. They're very flexible in how to do that. Version control them. Really treat those as you would any of your other proprietary kind of intellectual property, because that's what you're going to use to roll out and deploy your infrastructure across AWS. So let's take a look at just a really brief demo here. And we'll go back to that common scenario. Let's create a Linux instance for our developers. Let's have the systems manager agent installed and running. So one of the first things you'll see is CloudFormation already provides a set of templates that you can start with. And inside of that, you've got things such as EC2, Elastic Beanstalk, and even if you drill down into one of the sample templates, you'll see there's multiple versions already built out. You can use these directly by launching it, or you can actually view it. And here's a JSON template for an EC2 instance creation, and you can see all the instances in there, and we'll use that as our template. So we've taken that, we've modified it, we've limited the values of the instance types, we've set some parameter controls for SSH, we've set our AMI images in there that these instances will then use within each region. And last, we've said once the image is installed, or once the instance, let's go ahead and install the SSM agent. So I've got that template now created. I can go ahead and create my stack. And it's just as easy as specifying where you stored that template within S3, providing some additional parameters around that. And then go ahead and verify the information and create my stack, which at that point, we've gone ahead and ran that, and we now have the EC2 instance as we described it in code existing within our environment. So we've got our Linux Dev version 2.0 desktop there. So just a real quick kind of best practice is when you're creating templates, just like any source code, don't embed credentials in your template. Use specific parameter types. Use constraints. So the default templates themselves provide kind of the generic. Take it and tailor it. When deploying software applications, use things like CloudFormation init to deploy those. Use the latest helper scripts, so they're always being updated to make it easier for you to deploy applications once the instance is up and running. And then, just like you would any other type of source code, validate the templates. And you can do that directly within the CloudFormation visual designer. And then there's a deep dive on CloudFormation for those that are interested. So one of the questions then is, well, great, I've got my set of templates that are available, but how can I allow others within my organization, within my account, to deploy these templates in a very self-service manner? And I also don't want to give everybody access to CloudFormation and all of the templates strictly because of the power that they represent in creating resources in my account. So one of the other services that helps us do that is AWS Service Catalog. And AWS Service Catalog really allows organizations to create and manage catalogs of IT services. It's built on CloudFormation. And it enables you to quickly deploy approved IT resources in a self-service manner. So AWS Service Catalog is composed of a couple key terms in there, and it's things like portfolios, it's products, it's versioning. You're able to provide very granular access controls down to that portfolio product level. You're able to even set further constraints than what your CloudFormation template has built into it. And then, of course, it's built on the concept of stacks as well. So I thought what we'd do real quick is just a real simple service catalog demo where let's add the Linux instance as a new product for our engineers to provision while further controlling the instance size and the permissions around that. So within the console, there's a separate console directly for service catalog. And I'm in as an administrator here right now, so you can see I've already got a portfolio set up for my engineering tools. Within that portfolio, I've already got a product defined for my Linux Dev environment. And I've already got a base image in there, version 1.0, but I want to use the CloudFormation template. So I'm going to go ahead and create a new version to that. And again, it's as simple as once I've got CloudFormation templates defined, I can specify that as a product. I can give it a version. I can give it a description. And you'll see then we've got version 2.0. So I want to go back to the portfolio level and further set some constraints. So if you remember, our CloudFormation template had multiple versions in there. For my environment, I only want to allow the engineering team to self-provision T2 micro and T2 small. even though my template defined more. So I'm able to set a constraint within that product. Now if I go and look at it as an end user, as an engineer, as an employee, I'll see the dashboard where I can then select my product. I can choose which version I want to deploy, and I could have limited it so only version 2 was available to this user. And then self-provisioning, I can give it a name. I can allow some additional parameters to be set on there just for the user themselves. I could receive notifications if I wanted to know when the product was available, and then I can launch it. And you can see what's happening behind the scenes here is Service Catalog is now running the CloudFormation template that I built with the constraints that I added in a very controlled manner without having to give that user direct access to the resources themselves or to CloudFormation. And I can see now, again, another instance has been deployed using Service Catalog. So it's a very powerful way to create a portfolio of offerings, a group of products with versions, and deploy it based on my CloudFormation templates. So another question is, when building and configuring resources, how can I centrally define, control, and manage configuration data and secure parameters without hard coding? So if you remember a best practice, we don't want to hard code pieces of information into CloudFormation templates. And one of the ways that we can do that is through the Systems Manager parameter store. How many of you have used parameter store? So fewer. So parameter store is really a centralized location to manage your configuration data, including either plain text data or secrets. And you can actually encrypt your secret information or your secret strings using AWS KMS. So critical information can be stored within the environment, and that information can be referenced from CloudFormation. And I'll give you an example of that. So for those of you that have used CloudFormation templates, very standard to basically spell out your AMIs in the template itself. Well, what happens when you update your AMI and have a new version? You have to then go back into all of your CloudFormation templates and update that AMI ID. If you put those AMIs and versioning into parameter store, you now can set a variable within your CloudFormation template that will always pull what's available in parameter store, so you've always got the latest version and no longer have to go back in to your templates every time you update an AMI. Very, very powerful stuff. You can also reference parameter store from other services, such as run command, automation, state manager, we'll talk about those, as well as things like ECS and Lambda. So if you haven't taken a look and leveraged the value of parameter store, definitely worthwhile to do. So let's just take a quick look again at how to do that. Very, very simple to do. You could either go into the EC2 console, and on the left-hand side, parameter store, or now there's again, a new console for AWS Systems Manager where parameter store is also available. I can create a parameter simply by giving it a name, giving it a description, specifying whether I want it to be a string value, or in this case, I want it to be a secure string. So I'm going to go ahead and use my KMS key. I'm going to put my value in there, and then I'm going to create the parameter. I can see within the console what that value was. And now from within the instance in this case, and I'll just show a very, very simple Python script. Very simple, just using Python and Bodo 3. I'm going to create the SSM client. I'm going to get the requested parameter. I'm going to store that in a variable, and then I'm just going to print it out on the screen. But ideally, I would use this then in my Python code and my script. So now, instead of each developer having to remember all of their connection strings, as this example shows, they basically can reference parameter store. So as that string changes, they instantly get that change as well. So let's switch over then to the next section. And if you remember, after define, it was how do we discover and monitor resources that show up in my AWS account? And that's the question we really want to ask, is how can I view the details of activity within my account? For example, I want to see the details associated with the creation or the change of a resource. And in order to do that, we'll use AWS CloudTrail. I'm going to ask this question, and if you don't raise your hand, I'm going to call you out. Who is using CloudTrail today? Oh, that should be 100%. Should be 100%. AWS CloudTrail is a service that provides a history of account activity, including all of the actions taken, whether that be through the console, the SDKs, the command line, or by other AWS services themselves. And why that's important is really CloudTrail is one of the most used services to help you meet any of your compliance controls. And it does that by giving you durable and auditable activity logs. You can gain visibility into IAM user activity. You can detect access to sensitive data from unauthorized networks or IP addresses. You can use it operationally to troubleshoot misconfigured permissions from applications that you develop. All of that information is stored within CloudTrail. Because of the fundamental value, I wanted to provide just a few really quick best practices. And if you're not architected this way for CloudTrail, you should really think about changing. So one of the best practices is to create a trail within your account that applies to all regions and is really dedicated to an auditing security purpose. If you've got multiple accounts, you can point that trail to store its information in a centralized S3 bucket. So you've got then a single bucket where all of your accounts are storing CloudTrail information. And because you want to use that for audit and security, you want to make sure that you encrypt it with KMS, that you've got log file validation turned on, and that you're logging both read and write for both management and data events in there. Once you've got that centralized trail, then you can go ahead and create additional trails within the account for operational support, DevOps types needs. And then you'll want to then create some work stream based off of high value events, whether that's using CloudWatch events or other downstream services such as Amazon Athena to do queries, Kinesis Analytics to funnel data and pump that into other services such as Elasticsearch service, or even into another Kinesis stream itself. So another question that we want to ask, and this one has I really like this one, is how can I easily discover, if you think back to the example of a machine showing up underneath a developer's desk that's connected and has all of the dev tools already installed, how can I easily discover that type of resource? And how do I know where that resource was provisioned from and who provisioned it? And if you think of traditionally, that's an extremely difficult question to answer. You've got to have scans going on all the time. You've got to have all sorts of processes and things in place to be able to do that. And then it's just not uncommon to have things slip through. Very, very, very easy to set up in AWS. And you do that through AWS Config. And Config's a service that really enables you to assess, audit, and evaluate, discover resources, look at change history and configurations, and then start to provide rules to ensure that those resources and those configurations conform to the best practices and the definitions that you set at the beginning of this project. One of the ways you check that compliance is through AWS Config rules. So within Config, within the dashboard, you can instantly see your resources. You can then create config rules and think of config rules as business logic to check compliance against a control that you've defined. And some examples, you could either use managed ones, such as checking whether logging's enabled for your S3 buckets, identifying if an S3 bucket is publicly accessible, making sure that my EC2 volumes are encrypted, looking to see if someone has set a security group to allow SSH from an address outside of my corporate network. These are the types of rules that you can create. And in fact, the AWS security team on GitHub has mapped config rules to CIS benchmarking. So it's a CloudFormation template that you can go download today, apply to your environment. It will map config rules to the CIS benchmarking controls and instantly let you know within your environment what is in compliance and what is not in compliance with CIS benchmarking. And all of that can be done within about 60 minutes. And really 45 of that is letting things run. Really, really easy to do and extremely valuable, especially when you think of what that would look like in an on-premise traditional environment. So some common use cases, we've already talked about a few of these: tracking configurations over time, detecting misconfigurations, verifying compliance, and then change management. So let's take a quick look at a demo that combines CloudTrail and Config. And what we'll want to look at is how can we discover any instances that were created outside of our CloudFormation and Service Catalog provisioning process. And then while we're at it, let's just see if any of our developers have opened up SSH access outside of our corporate network. So you can see, starting with config in the dashboard, you instantly get a view of what assets exist within your AWS account. You can see things such as EC2 instances, volumes. You can drill down into S3 buckets and start to see what S3 buckets exist. But let's go ahead and add a rule. AWS has a set of rules you can start with, or you can define a custom rule. And a custom config rule is really built on Lambda functions. So you can practically define any type of validation or rule using Lambda within config. For this demo, we'll go ahead and just use one. So we want to look for tags, because we know using CloudFormation, it sets AWS reserved tags. So CloudFormation has its own set of tags that we'll specifically look for. So we'll start with that template and make it our own. We know that we only want to, for this demo, apply that to EC2 instances. So we'll just remove what doesn't apply for this particular rule. We could have left those in there. We could have looked at all things. Again, very, very flexible, very easy to do. But we know that the key value that we want to look for from CloudFormation is right there. So we'll go ahead and save that rule, which then instantly starts to evaluate our AWS account against that criteria. And while that's evaluating, we'll go ahead and just use the manage rule for SSH access. We'll leave it by default. It's a common request to see if there's any EC2 security groups with SSH access open to everyone. We'll use it by default, and we'll let that run as well. And you can see when these are done running, it instantly found I've got 2 non-compliant resources, meaning they were created outside of my CloudFormation Service Catalog process. And I can instantly see what those are. So I can see here are the 2 instances, and I can actually jump right to the timeline. So I can see when that instance was created, what changes were associated with that. I can see what relationships that instance has. So here's my networking interface, here's my security groups, here's my subnets. All the details we would want to see are right there. If I want to look at more, I can actually open up the CloudTrail log associated with the creation of this resource. And I can see that the user, Bob Odell, created this outside of my process. And then if I really want to dig into the detail, I can actually directly from here see the CloudTrail log itself, which then has all of the CloudTrail information from user identity information to request parameters to response details to any additional data associated with it. Now again, think about in a traditional environment. That's such a hard task to accomplish. Very, very easy to do through a combination of config and CloudTrail. I also can jump directly to that instance within my EC2 console, which then I could terminate that if I wanted to, or I could isolate it into its own security group so it can't impact any additional resources within my account. I can also look at the SSH. So I've got one resource that wasn't compliant. Again, same thing. Very easy to drill into it and identify exactly what the history of that resource was. So if I look at the most recent changes with that, I can again see that it went from a restriction of my corporate network to opened up to basically the world. So now anyone could attempt to SSH into the resources that are behind that security group. We can also see that we're going to have a talk with Bob Odell, because he, again, is the person that opened that up. So what you've got there is a developer, potentially, that is creating his own instances. He's got too much permissions within the account. He's modifying security groups. He's working fast. And we're able to see all of that through a combination of config and CloudTrail. So another question we want to ask is, how can I monitor the specific state of a resource and discover software that's actually running on my instances? I know that I've defined what my AMI should look like. I know I've defined what packages should be running on that. And I want to get a good idea of is everything the same as I originally set it? So there's two services that we can use to do that. We can use the Systems Manager, State Manager, and Inventory. And State Manager is really a way to define and maintain a consistent configuration or running resources on a very scheduled type of event. And Inventory is the service that provides visibility into the software catalog and configuration. And this is an important note on both your EC2 instances as well as on your on-premise servers. And it works for both Linux as well as Windows. So the ability to monitor configuration state through state managers is a pretty powerful tool in itself, and it lets you control configuration details such as antivirus settings or IP tables. So I could consistently reapply a set of IP table rules to an instance. That way I've got some level of guarantee that those remain the way that I intend them to remain. And I can automatically apply that policy on a defined schedule for OS changes, as well as local users and permissions. Inventory lets me discover the installed software applications, the patches, the Windows updates, and I can sync that inventory data both with config, as well as send it to an Amazon S3 storage. So if I'm managing multiple accounts, multiple regions, I can run inventory and output all of the inventory of all of my instances into S3, which then I could run some analytics tools and think of a use case around licensing. So I want to identify how many licenses of a certain package or a certain application that I have running across all of my accounts. Inventory allows you to do that. So let's take a look at a demo where we're going to use State Manager to perform the inventory collection. We're going to use a couple documents to do that, and I'll explain what those are. And then we're going to set up a config rule where I know that I don't want to have a certain version because it's very vulnerable, it has issues. I don't want to have that version of FTP software installed on any of my Linux dev environments out there. So again, within the config dashboard, we'll go ahead and switch over to the EC2 console, or again, this is now available in the AWS Systems Manager console. On the left-hand side, we'll take a look real quick at State Manager. We'll go ahead and create what's called an association. An association is really applying what's, again, called a document. So think of a document similar to a CloudFormation template. It's actions that I define that I want to have happen. And again, there's a set of defined documents already available. One of those is Get Software Inventory. So we're going to go ahead and choose that. We're going to apply it to all of our CloudFormation templates. We could specify it by tag. We could specify it by individual instances. We can set the schedule of how often we want this association and document to run. And then we could choose any number of parameters associated with this. So for instance, the inventory already provides a list of different types of components that we can collect inventory for. You could also take this document and make it your own. You could add different types of inventory that you want to collect. So again, very programmatic, and also should be treated similar to templates as source for you. So once we've configured the parameters associated with that document, we can go ahead and apply that. And here what we're doing is we're also then just going to apply the SSM agent. If you remember in our CloudFormation template, we actually installed the SSM agent and ensured it was running after our instance spun up. Here we just want to make sure that it stays up to date. So we're going to go ahead and just make sure that this runs and keeps the SSM agent on our instances up to date. And then we'll create that association as well. And we can see that our inventory has already completed. So let's go ahead and take a look at what that looks like. And if I go into my instance, I can see now it's got a full inventory associated with it. I can look at any of the applications, again, any of the networking components, any of the things that I defined in my document, I can now start to look at. I could output this again to S3 where I could start to run things like Athena queries on it across multiple instances or fleets of instances. But for this case, it's already available in config. So once inventory runs, config knows about that inventory. And there's actually a manage rule today for blacklisted types of applications. So I'm going to use the manage rule, and I'm going to go ahead and look for this particular version of FTP that I know I don't want running in my environment. Once that config rule is done evaluating, you can see it identified that I've got an EC2 instance that basically is non-compliant with that. So I've got that running in my environment. Again, very, very powerful tool to be able to set a definition around what you expect to be running, be able to discover that, be able to monitor that, and then be able to take action against that. So last, let's look at, again, kind of the final part as we defined it. How do we manage, report, and respond to changes in our environment? And a question we'll ask ourselves here is how can I create a maintenance window where I can run automated types actions on my instances? I can manage compliance with required operating patch levels. And two services that help us do that are Systems Manager Maintenance Window and Systems Manager Patch Manager. Pretty self-explanatory on what these are. We're all familiar with maintenance windows, and we all live in a world where maintaining patches for the instances that we have to become a really critical job for us. So another question that we want to ask is how can I allow developers and administrators to run command on individual instances or across fleets of instances without SSH. With that, I want to make sure I've got really detailed logging, and I want to limit the blast radius of any command or script that runs so that it doesn't impact large workloads that I have. And a service that we have to do that is Systems Manager Run Command. And I'll ask again, how many of you have actually used Run Command? Great, great tool. So Run Command allows you to remotely and securely really manage, services at scale. You can use Run Command to run scripts or documents again on single instances or across fleets of instances, and all without having to open up or allow SSH on those instances themselves. So I want to look at a quick demo here of where we'll look at a maintenance window, we'll look at the compliance with our patch manager run, and then we'll focus on how can we look at a run command demo itself. And the way we'll do that is we'll use Run Command to update and add a new approved application. So I know that I have now allowed the use of a new Java package tool, and I want to be able to deploy that across all of my developer instances without having to have them do it themselves or open up SSH access for them. So if we look at the Systems Manager, and we'll just kind of jump right into the patch compliance here. So I've already set up, I've already run my patch manager, and I can instantly see what the results are across the patch baseline that I established with my instances. I can define what that baseline looks like. So there's some, again, defaults that are updated with the latest. But if I know that there's something that I specifically want to look for, that's part of my deployment or part of my AMI, I can add that into the document and specifically look for the versioning of that. So from a run command perspective, first what we'll show here is let's just look to see what version of the package exists on this instance itself. So here we can see that we've got a version installed, but we've got a newer version that's available. And what I'll do is I want now to create a run command that will update that package across a wide group of instances themselves. So one of the documents within run command for Linux is the run shell script. And I'm going to go ahead and apply this to all of my instances, all 2 of them. It could be an extremely large set. But here's what's important is I can say I want to execute this script on either X number of targets or a percentage of my fleet. And if I encounter more than X number of errors, I want to stop that deployment. I no longer want it to go forward. So you can control the blast radius of executing run commands to ensure that you don't take down applications or services or workloads. If I want to run that through the CLI, run command actually outputs that in CLI format that I could run individually to test on. And then as I run that against an instance, you can instantly see the results of that as they come back as well. So I can see that this successfully ran. It updated the Java package. I can go back into the command line on that instance itself and now see that that version is what's running and what's installed on the machine. Now, one of the other great things about run command is all of the actions that just occurred are also logged in CloudTrail. So you've got full auditability, full transparency of actions that were taken on your AWS resources. You will see the run command. You will see who executed the run command. You'll see the details associated with that. Things you don't have access to through running SSH directly in most cases. So here's another question that we want to ask ourselves, again, in the manage, in the report, in the respond. Well, I've already got a large investment in either Chef, Automate, or Puppet Enterprise. What's available within AWS management tools to help me? And that's where OpsWorks comes in. How many of you have used OpsWorks? Okay. So recently, OpsWorks started in OpsWorks Stack, which was a version of Chef. There's also a managed Chef version. So we've got OpsWorks for Chef Automate, which is basically a managed instance of Chef, where we'll do the updates, we'll do the patches, we'll do the backups. Not too long ago, we released OpsWorks for Puppet Enterprise. And same functionality allows you to use your existing documents, your existing manifests, your existing recipes, all within a managed version of either Chef Automate or Puppet Enterprise. Some of the value for that, again, is fully managed, programmable infrastructure, scaling made easy, support from a very active community, whether that be Chef or Puppet, secured, and very simple to manage. So again, fits all of the criteria that we talked about, but leverages an existing investment you may already have in one of those configuration or management tools. So one of the other questions, and this will be the final one, is how can I create visuals that help monitor my AWS environment and alert on any high-value events or activities? And that's where Amazon CloudWatch comes in. And think of CloudWatch as really three kind of core aspects. The first one is CloudWatch metrics and alarms. So I want to be able to collect and track both predefined and custom metrics. And I want to be able to set alarms based on the thresholds. So those could be things such as CPU utilization, memory utilization. And I want to be able to set thresholds that if they exceed certain amounts, I want to be able to get notified about that. I can also set it on things that one of the other parts of CloudWatch is CloudWatch logs. So CloudWatch logs is really a centralized location where I can put all of my log data, including CloudTrail data. So any of the CloudTrail logs, I can actually forward into CloudWatch logs, as well as my custom applications, as well as my platform. Everything can go in there, and I can then create custom metrics and custom alarms on that as well. One of the last pieces of CloudWatch is CloudWatch Events. And CloudWatch Events is leveraged heavily with CloudTrail as well. So CloudWatch Events is really a way to match events. You can go into CloudWatch Events and you can create a rule based on a very specific pattern that you want to look for. So I could create a rule that says, I want to know when root activity occurs within my account. And I want to be able then to route that alert, as well as the details of it, to a downstream target. And that target could be a Lambda function, it could be a Kinesis firehose delivery, it could be a Kinesis stream, it could be a run command. So I could set it up to say, if I see a create instance CloudTrail event, and it doesn't match my criteria, I want to use a run command or automation to isolate that instance off of my network so that it doesn't impact things, and this can be automatic. At the same time, I want to send an SNS notification to my security group so they can instantly look into that, while again, that instance is not impacting any of my current production workloads. And a lot of that can be done through setting a CloudWatch event rule. So some of the values are just the ability to do monitoring of both EC2 as well as AWS resources, as well as custom metrics, being able to store your alarms, set custom thresholds, and then view graphs and statistics around that. So if we go back to that common scenario that we started with about building a new application, of developing and responding to our customer needs, but doing it very quickly at a very low cost and ensuring compliance with security and risk auditing, hopefully what you've got the sense from this discussion is how AWS management tools can really help you do that. And you can do it in a very programmatic, very scalable, very easy way. But we've been able to show how to define your resources, again, with services such as CloudFormation, provision those out in a self-service manner with Service Catalog, leverage parameter store so that you're not hard-coding strings and sensitive details within your templates or within your code itself, discover new assets that show up with tools such as Config, and then being able to see the details around those and have an audit tracking very durable storage with CloudTrail. Being able to then further create config rules to check compliance with those resources. And then using systems manager tools such as State Manager, Inventory to further identify and discover what's running on those. And then being able to manage. Being able to manage, whether it's through a managed service such as OpsWorks for Chef Automate or OpsWorks for Puppet Enterprise, or being able to do it yourself through systems manager tools such as Run Command. Very, very powerful set of tools that, again, are very simple to deploy. But if you think of executing those same pieces in an on-premise traditional environment, extremely difficult to do. So this is what will help, combined with the other value of the AWS cloud, to achieve these types of new applications, these types of common projects that continue to come up. And then we've got a host of customers that are already leveraging these tools, all the way from, again, you heard Expedia, Zendesk is using them, Cloud Health, Autodesk, Netflix, large-scale companies that have built infrastructures around leveraging management tools to help govern and become compliant with their business practices. So hopefully that gave you guys a sense of AWS management tools and how you can apply them to your environment. I appreciate everybody coming. I'll stick around for questions afterwards, but I hope everyone really enjoys reInvent and got some value out of our discussion today. Thank you.